All right, so on this one, we have an electronic store received a shipment of 30 graphing calculators, including six that are defective. Four of these calculators are selected for a local high school. How many selections can be made? Well, we're taking the 30 calculators and we're selecting, on this case, four of them. All right, so order here doesn't matter because all the calculators should be identical. And so for A, we're just going to say 30C4. Okay. Now, B, though, says now it cannot contain a defective calculator. Well, how is that possible? Well, if it doesn't contain a defective one, that means we're taking out all the defective ones. So we basically checked them all, turned them all on, taken them out. And so how many is left? Well, if we take 30 minus 6, there's only 24 of the calculators left. And again, we're still going to choose four of those calculators. And so that's going to be the number of ways that there's not going to be a defective calculator. Okay, again, we took those out. That's the total number. So when we do this, there's going to be some defective calculators possible in here. When we do this one, there's not going to be any defective calculators. So if we do that, let's clear that out. So what we have then is math. We're doing combinations again. So it's going to be 30C4. So we get 27,405. And then after this, instead of 30, we subtracted out those 6. So we only have 24C4. And in this case, we get 10,626. Okay. So a lot less when we subtract out all the broken ones. And so when we do that, that gave us then the 27,405. And this was the 10,626. Okay. So the key is, what are they really asking for at which point in time? How many selections can be made? Well, there's 30 possible out of, and we're taking four of them. This one, we get rid of all the defectives, so we subtract those out, and then we choose our four from there. All right, so let's stop there. We'll come back for some more.